Hello all, I hope you are doing good. So, yeah, let's start with today's class. Today, we are going to discuss a lot of things related to. Uh, Let me start my class. Let me share my screen. So, we are going to discuss a lot of things today. So, first thing we are going to discuss is I'll be teaching you one of the service, which is a serverless service provided by AWS. Okay, we're going to learn about this S3, one of the storage service, which is a serverless service provided by AWS. Okay, and we're going to learn much concepts called like chorus, what is microservices, and we'll be building a nice project. Okay, where whatever we learned till date. Okay, we are going to combine all those things and build a nice project. Okay, using microservice. Okay, and we'll be discussing whatever the required solid principles which we'll be covering. Okay, I don't want to like confuse you a lot, but I'll just explain what are necessary things in our class. Okay, so yeah, coming to the first thing, let's start with the one of the serverless service. Okay, you already know what is serverless and all the things. I'm just jumping into one of the service called S3. Okay, so once you go to the dashboard, once you type S3, yeah, it says like scalable storage in the cloud. Let's just open it. This is one of the best service provided by AWS and many services which internally uses Amazon. Okay, for storage purposes, Amazon S3 for storing a lot of data. Okay, I mean data. There might be files. There might be any data kind of thing. Okay, we're going to store in Amazon to do some operations on it. Okay, or just to store like hard disk. Okay, so many services use this. Even when we learned AMI, right? It creates an image. Even that image is stored in S3 to have faster retrieval. Okay, so I'll just give a brief intro. What is S3? S3 is something like it's like a hard disk. Okay, you can think like hard disk, but it's not exactly an hard disk. But they have a specific way. Okay, to store the data. Okay, they call it as like objects. Okay, they store like objects. Okay, these are like they store in a particular format so that they are like much easier to access and much easier to store. There are like many things within it. Okay, we already know, right? Whatever we do on the data is like a CRUD operations, right? So here also we just put the data, delete the data, or here we call it as objects, right? So it's like a files. Okay, objects are nothing but files. So here we'll be doing like we'll be keeping the files into something which we call it as like folder. Okay, let me tell you, like here folder is nothing but bucket. Okay, we call it as bucket, and inside the buckets we keep files where they call it as like objects. So we'll keep the objects within the bucket. Okay, while keeping they call it as put, while deleting we call it as delete, and something like we have like get. Okay, get is something like to get the file or the object in terms of history terminology. Okay, why these name came is one of the good advantage of S3 is it works on HTTPS protocol. Okay, so that's why we have these kind of methods to access and delete or do any managing kind of things on the files is much easier. Just to like do get, you'll get the file or object. Just delete it. Just single request, it will just delete it. So it's as easy as we want. Okay, so that's one of the easiest way and to manage files or objects. And once you just go through the documentation, right? S3 has one of the best documentation. AWS S3 documentation. You can just type like this. You'll get what features does it gives. It has a nice features, something like user guide. You can go through it. It has one of the best storage services, right? Storage services, storage management, how to store it, and it even has like which hard disk devices you need to use to have the best performance. And it has a lot of things to manage, right? For storing, logging, data processing, and access management. They just have everything on top of the buckets and objects. You just can just go through it. There are a lot of features provided by Amazon on S3. You can go through it. But I was just looking for one thing. Yeah, so you can see the REST API, right? Whatever I was saying, like the code operations, you can just easily perform on top of it. So yeah, so you can just go through it, go through the documentation. But for now, we are going to just create one bucket. That means like we are going to create a folder. We're going to add some files. Okay, which is as straightforward as it is. Okay, and we're going to move forward in our project. How we're going to build. Okay, first go to this and just click create bucket. I just want to show you before how we are going to do this completely automatic using serverless framework. But for now, you can just think like we're doing manually. Okay, this is like general purpose in which region you're going to keep. and you should definitely give the bucket name unique, okay, always across the globe. Actually, the global names is. So I'm just giving like AWS training 2025, something like this. I hope no one has taken this kind of bucket name. And these ACLs and other things you can just keep by default. Okay, we'll be changing these public access to the bucket for now. Let's just let it be like this. Let's just create a bucket. Okay, fail to create it, the bucket name. Uh, Special bucket name is already taken. Bucket name should be unique. So the name should be changed to something like serverless. Okay, click create bucket. That's it. It just creates a bucket. So it's like creating a folder. Just open it. You can upload files here. I'll just upload some sample files. For that, just do upload, or you can upload here. Okay. Even you can just create subfolders or sub buckets within this one. You can do that. But I'm just straightforwardly adding some files, whatever the file I have. Something like index.html, some other files you can add it. For now, I'm just adding index.html file. So you can see something like there are like many things like properties, permissions. You don't have permissions for now. Okay, but for properties you can just select which storage you want to do. It's like which hard disk, is it SSD or something like that you normally have, right? Similarly, we have different storage classes for best optimization. Okay, this is like a place where many architects will be planning properly for cost optimizations, but don't bother about it. I'm just going with the standard, which is like for frequently accessing data. uh, and just make sure like keep all the default ones. Okay, server side encryption, a lot of options they give. Okay, to change what kind of encryption they should be done, checksum, and just ignore it. Okay, just do like upload. You just did one thing, that is you just created a folder called this one, and you uploaded a file called index.html. That's it. Okay, to access it, okay, we normally need some kind of permissions. Okay, we call it as like ACLs. Okay, by default, they removed the old ones, but now they added something like policies. We can add the policy, but before doing that, let me just allow the public access for now. Okay, so that we can access the file. But it's a recommended thing that we don't do this public access, and we just give access to only specific people. Okay, for now, just I'm just giving public access for now. Okay, to just demonstrate how it works. And now we gave the public access to the bucket level. Okay, this is bucket settings. That is, anyone can access this folder, but they can't access the files. Something like that, the permission they kept. But we need the permission to this object or this file. So for that, they created something like, if you go to permissions tab, here they have bucket policy. Okay, you can edit it and say like all the bucket objects within that bucket should be available. Okay, so here we need to generate this policy. I'll just quickly generate it. You can go here, policy generator, click here. You can select the S3 bucket policy here. I'm just going quickly, just to not invest a lot of time in these basic operations. We're going to build a bigger project. Okay. So principal, you can just keep like star all the principals or anyone. And actions I'm just giving all, or else you can just select get or any operation. You can just click get. So get permissions, a lot of things are there, right? Get bucket policy, get data access, something like that. Get object is what we need. Okay, we can select this one. Okay, or else you can just select all. Anything is fine. For resource, just select all for now and just add this statement. Okay, generate policy. You can copy this policy and just paste here. Okay, here resource normally we should not give a star. Okay, the resource should be this ARN. Okay, and this within that ARN we'll be giving the access to all the buckets. This star means all the objects within the even objects and buckets within this main bucket. Okay, so you can just save changes, and you can just come down. There is nothing other changes to be done. You can now access this file. How? You can come outside, click on this object or file, and here you can see there is an open this one, or else you can just use this one. Anything is fine. You just click open. You can see this is a file. Okay. So if there is no permissions, you definitely won't able to see the file. So this is like basic overview of S3, how to create, how to store the files within this or objects within the bucket. Okay. So why we are doing this? Because I'm going to use in my one of the project. Okay, this complete so full stack product, right? Using a microservice. So I'll just give you the overview of S3, how the serverless service work. That is one of the S3. So it's a serverless service. So we can definitely build that using a serverless framework. Okay, and yeah, let's go and learn about more other things. But before going to this, let's build our project. Okay, slowly I'll just explain where we are going to see some problems and other things. Okay, so yeah, the what project we're going to do is, okay, we have something like, there is like a form. Okay, where we'll be getting the name. Okay, uh, name and a email. Okay, something like this we are going to get. We can have many fields, but now for now I just took two fields. This is a form, which is a front end form. Front end. Okay, once a user comes, this is on a top of browser. Okay, this runs on browser, and once a user come or a client or a user comes, enters this form, then once he submits it, it goes to our backend service. Okay, we have another service. This is completely on AWS. Okay, this is in completely on AWS. Okay, even this front end, okay, we'll be deploying on AWS in S3. Okay, I'll show you how it works. Okay, but don't focus on that for now. Just focus on what we're going to build. Okay, so we have another service called uh, uh, store service, something like this. Store service, where we'll be taking this name and email and store it in DynamoDB. Whatever we did in last class, right? We stored some data into the DynamoDB table. Okay. So similarly, what we'll do is we'll take these details, we'll store in the Dynamo. Once this DynamoDB is executed, okay, we have something like the streams. It automatically triggers an event. Okay. So this is a Lambda service which is triggered by a user. Okay, we have an API gateway over here. Okay, this API gateway will redirect to this one. Okay, this service, and we'll have another project. Okay, which is like once you store in the DynamoDB table, it triggers another Lambda. Okay, which we call it as another service called email service. Okay, service. Okay, so this is a event which is not triggered by a human, but it's just triggered by a service. Okay, so we normally learned, right, when a service is triggered on a service, we'll be creating another role over here for this service to have access to the service. Here there should be another role. Okay, by default we'll be creating this is like just a form data, and there is a Lambda, there is a gateway. Okay, gateway has specific permissions. We'll do that. Okay, here we'll be coming a concept called a chorus, to whom you to enable and from where we need to get the request. Okay, and this is a public page, and they can hit it to this API gateway. Something like this we're going to do. Okay, I'll just show you the code. This complete project will be an automatic way. Okay, once we trigger this event, this email will send a email to whom, whatever the email which we gave to those people, will be going to send an email. So this is one of the nice project. Okay, here whatever the service we kept, right, this we call it as like microservice-based architecture. Okay, this is the common way of building the projects in the large scale enterprise teams. Okay, so what they do is like they reduce the amount of work they each service has to do. Okay, and they like normally keep for like any enhancements in future. Okay, there is a term called like solid principles, right? In solid there is like S, right? This is like it has to have only single responsibility. Okay, S is something like single responsibility, right? So it's like this service doesn't do anything to other than the storing in the data DynamoDB data. Okay, or database. It does not do anything other than that. This DynamoDB also has only a single service or responsibility, just to trigger an event and send to the email service. That's it. So they have only single responsibility. If you see here, the email service, it doesn't do anything, just to send an email to that response to user. Other than that, it doesn't do anything. Okay, that responsibility has end till there itself. Okay, so that's why in solid principles we call S as single responsibility model, and O is something like open for any enhancements. Let's assume, okay, there is a possibility like, okay, in email service there is like email template, right? Okay, whatever the template in future, if you want to change, they can come to this service or this Lambda and just give a new template, and that new template will be sending directly to that new email address. Okay, so something like that, we can do a lot of enhancements. We can do the changes, how to send, from which email address they want to send the email, and all the things they can do. Even in the store also, they can change the DynamoDB table. They can do how they want to store the data in the DynamoDB. They can just change it. Okay, there are many possibilities that, okay, in this architecture, there might be another team. Okay, they will be connecting to this DynamoDB. Okay, there is another team. There might be some other microservice completely. Okay, uh, okay, we call it as like downstream APIs. They might connect to this one. Okay, and get some data from this table. So they might need the data in some other format. Okay, so they might ask us to give in the right format to send to them, something like that. If we are using only, and there is no external scheme, then in that case we can keep however we need in our service, so in our DynamoDB table. So something like this, there is like microservice based architecture. Each service or Lambda going to do some particular task. Okay, so in our previous class we did this microservice, now we are going to create another some microservice, something like this. Okay, this is also another microservice, but this is something like we are going to just deploy it in the S3 bucket. It acts like a front end bucket, but in the backend there will be another service provided by AWS itself. It hosts it entirely. They'll manage everything for us. You don't have to worry about it. Okay, and the connectivity part we need to do it. Okay, so this is like complete microservice based architecture and how solid principles, right? So we discussed, but LID we can discuss whenever we require. Okay, so yeah, we discussed about microservice and solid principles and what we're going to build. So this chorus will be discussing in the upcoming project. Okay, so yeah, let me share my project, okay, with you. Okay, so these are the three things. Okay, first let me build my front end, no, not the front end but the back end, and I'll show you the front end part, how it's going to build. Okay, how we are going to store the files in our S3 bucket and how we are going to host it. So yeah, let's open it. uh, so yeah, let me start with user service. Okay, this is something like we are going to store the data in the Dynamo. We assume there is some data going to come to the API gateway. We're going to create API gateway and the Lambda. Okay, we are going to connect automatically this API gateway to this DynamoDB Lambda storage service. Okay, so there is nothing in this. It's as straightforward as it is. Once you open the serverless, you can see, ignore this provider because we're going to AWS Python. The region, the stage is mostly given to the API gateway, and the environment, right? Environment is like environment variables. We need the user table where the DynamoDB table is, where we're going to store it. This table we're going to use it in our data get here. And IAM role, right? I said this is one of the good way to learn, right? So this is a service. I said it's as only single responsibility. So what it does is like it just stores the database, DynamoDB. That's it. So the data in the DynamoDB. This DynamoDB has what thing? It triggers an event. That's it. So there is like only one or two operations done by this Lambda service. So it what it does is we need to give only those permissions to it. So it's like we are going to restrict what all access or permissions or some operations it can do. Okay, so that's how we are going to give here. So you can clearly see this service has only few roles or few permissions, and this microservice has only few roles or few permissions. So that's how we are going to give. That's the good architecture to build a bigger system. Okay, so this is a nice place to learn these things. Okay, so what action I'm giving, this it can do only put, it even can't do get item. I think in the class I explained it doesn't need get item. Okay, put item, it just puts it, and the resource is only this table. Other tables I'm not giving access to this Lambda service. Okay, of course for logging I just gave the log things, and resource I give everything, but you can just specify how the log group name should be there. Okay, based on that you can just specify that resource name. And yeah, that's about this provider. If you come to functions, I said we are going to store the data, right? I created a stored user Lambda, and it's going to create a API gateway, and I enabled chorus here. Okay, chorus is something like, I'll just explain it quickly why we need this. Okay, in previous class why we didn't use it. Okay, so the thing is, whenever you hit from non-browser, right? Okay, from applications like Postman or Bruno, right? So we normally used Postman in our previous class, so there was no issue at all. But we triggered to API gateway endpoint, right? So we didn't had any issue. But now in our scenario, the browser or front-end application is going to do some request to this service. Okay, in this scenario, browser made sure that there are two systems. Okay, there are two systems which are connecting to each other, and this system is trying to get some data from here to this system. Okay, so the browser, what it does is like it makes sure there are no like vulnerabilities or some extra unwanted data is coming from the server. Okay, or the server makes sure that this user is a valid user to come to me, something like that validations they do. Okay, we call it as like we normally say like this is one origin or one system or one server, this is another system or server or origin, something like that. Okay, this is one origin and this is one origin. Okay, origin is something like a system. Okay, it has a different domain name, so that's the region we call it as like different origin or different IP it has. Okay, so whenever two origins, we call it as like cross origin. Okay, cross origin. Okay, when you need some data from cross origin, okay, we get a issue like cross origin chorus error. Okay, resource sharing. So this is like there is cross origin, and it is trying to the front end is trying to get or do some operation on these resources, that is to store the data on the DynamoDB, something like that. There is some resource, right? Resource is something like few service, okay. And this resource, right, is it's they're trying to share, okay. So this resource sharing is happening to another origin. So that's the reason we call it as like cross origin resource sharing. Okay, this is the better way to understand chorus and why chorus errors happen. Okay, so we are trying to share the resource to another origin. Okay, and the browser will make sure that this user or origin who is trying to request to this origin has respect to permission, and this origin is trying to allow it. Okay, how we are going to allow is something like we have headers. Okay, so in headers, we are going to specify that how we are going to allow or which origin has to be allowed. Okay. So in normally when you do cross origin, we'll be getting error like chorus. But if the resource sharing origin, right, this is the origin which will be telling like, okay, this origin or this user is good to access this resource, something like that. It will be sending to the browser, and browser will make sure to give access to it. So yeah, this is a good place to understand the chorus. So that's why I enabled the chorus over this service. Okay, and you need it will be like sending these all headers, but you can just ignore it. Content type, these all things. Allow credentials false, but you can just focus on the origin, right? I enabled all origins, but you can always replace this with this front end URL, right? I'll be showing you. You'll be getting a front end URL. You can copy paste here, but now I'm just allowing all origins. Okay, and yeah, this is how it's going to create. But you can just have a look at it. I'll be sharing this entire code. And what this Lambda service is going to do is serverless. It's going to create a table. Similarly, we learned right in our previous class with what attributes, one ID, and this is like attribute type, schema type, and we're going to add it. And we are going to have like stream specification, this new image, and we are going to like have outputs. We are going to get the ARN right here, and we're going to use this ARN in another service. We are going to keep this outputs folder. Okay, just don't focus much on these all things. You can think like we are going to create a table, DynamoDB table, and we are going to have an attribute called ID. Okay, and we're going to have streams, which is something like it's going to trigger another Lambda service. Okay, so yeah, let me run this one. Okay, this project. Okay, we can just go through this store user also. It doesn't have much thing. It will be getting a request from user. We'll take name and email and just create a new object and store it in the put item. Store it in the DynamoDB table. That's it, in the user table, which is coming from env. So that's it. We're going to return the response to the user based on the things. So what I was discussing is this one. Okay, we'll be sending to the all origins where we are coming. But normally we keep the origin here, and we'll be sending something like these all headers to the front end, and what requests these all origins can do. Other than options, post and get, no other request can be sent here. We'll be getting chorus error. Okay, I'll be showing in future what happens if you send other requests. Okay. Uh, Okay, that's it. So this is the thing. Let's deploy it. It's as easy as possible. It's like SLS deploy. That's it. It's a single command. You're going to build this entire architecture. That is this one. It's completed. Okay, and we'll be now deploying this one. We already did these two. Okay, the only thing we didn't do is this event thing. I showed you just now, right? The event creation. The event creation is happening over here. Event specification stream view type. This is event place. It's going to trigger the email service. How it happens, I'll just show you. Okay, we'll be adding this one, and we'll be having another thing called we'll be adding in the email service. Come down, you can see this one, this event stream, right? We're going to trigger from this stream called DynamoDB table, and that ARN this table name, this one. So I'll just explain this one. Meanwhile, it gets deployed. Okay, this is email service. It doesn't do anything, just to send an email. So it has same details like dev. We gave this from email, right, in our previous class. Similarly, we had this logic. I just hardcoded the email ID and the table name, and it's the same DynamoDB table name. The IAM role, right? So I just said, right, each microservice has specific roles. This doesn't do anything to just to send an email to SMS, SES, sorry. So we are going to allow to send email, send raw email. That's it. These are the two things we're going to allow. On which resource we can just give the resource name, but we can allow all the resources for now. Uh, and Dynamo get records, right. We are going to read the data from the stream of DynamoDB. So we need this access, or we can just do like star to get all the uh, things, but we need to have only these things. Okay, why delete? Because where I'm going to delete once I send a email. That's why I need delete and a list streams to list it. Get iterator, get records, description. There are like few dependencies to get the data from DynamoDB, something like that in all resource. But you can just specify the table name here, which is a good way to do, and restrict what resources this lambda can be uh, get, something like we'll be giving this table name, something like this. Okay, you should copy paste it. And logs, I already said, right? For this lambda, we're going to give few log group and it stores it. We can always give the resource name to specifically say from for which logs it can store. And I created one lambda function. It doesn't have any API gateway. You can clearly see we named it as stream. Why? Because we already created this stream here. From here, we are going to connect to this stream of DynamoDB, and that whenever a new record comes and stored in DynamoDB, immediately we are going to call this lambda email lambda, and it will run this function. What we wrote in this function? Nothing, just to send a email. So if you see this, we'll take the event. Okay, some passing is I'm doing just doing to just have exception handling and send some missing code, something like that, status codes. But you can make sure to just go through these things. I just added for extra uh, responses, right? Whenever we don't have email or table name, we'll be sending this status code to the front end to make sure that the front end knows what happens. Okay, or we'll be sending this to the other service actually, not to the front end, this service, because the event has happened from here. So yeah, so if you see here, I took the DynamoDB record. Okay, this is how you are going to read a stream. We are getting an event, right? In event we have records. There is some common JSON object for each stream event. Okay, you can go through this on online, but for now you can think like we get a records array, and that each record we are going to have a DynamoDB and new image, something like this. We gave, right, new image like this. So it takes it and reads the email name ID from the DynamoDB record. Okay, and we are going to create a template. So I said, right, we are going to have some new template here. If in future, if there are some changes we need, they can create a new template and add it here and send that to email, something like this. Okay, we'll be sent an email and we'll be deleting the item. What I said, right? Once we send an email, we're going to delete it. But if you want to restrain, you can just comment out this one, and that record will be there. But I'm just making sure to delete it so that the email has sent like that successfully. I add some exception handling, make sure to deletes properly. But you can add another extra features like make sure to revert back if there is any failure. Okay, failure case also you can make sure to have. But right now we just stick to this one. Let me just deploy it. So now what we did is we created this API gateway and this Lambda and the DynamoDB, and we are going to create connect these events to email service, this email Lambda, and send an email to this email using SES. Okay, so we always can go to this cloud formation, right? Cloud formation, and check whether it is running properly or not. So it just created completed. That means there are no errors. You can go to the Lambda and check the Lambda got created or not, and even the API gateway, right? API gateway. Go to API gateway. Check yes, the user storage API gateway got created. You can just click. There is a post method. As I said, we created, right. You can always come here. You can check it. What method we created, what route we created, like slash register or post, and the other chorus enable things. Okay, you can just go through here. You can edit it and just do those changes here. Okay, these options by default we're going to add it. It's a good way to do for post. It's a pre-flight, so it will check is there any chorus errors at first, and then we're going to send the post request if it doesn't fail. Something like that it happens in backend. So yeah, if you can see, I think it already ran. It got created the email service also. But if you see, there is no API gateway for email as we are not going to connect that API gateway to this Lambda. Okay, only to this store only we're going to connect. And click here. You can clearly see the stages and the route, right? So it's to this register. And if you go to the lambdas, we got two lambdas, and you can always come and check the DynamoDB. We need to have one DynamoDB to store the users, and from that table, okay, we are going to have streams. You can just explore tables. There is no data for now. Okay, you can click view tables. So again, back to that things like settings. All you can check here. If you come down, you can clearly see. Not in this one. You can you go to exports and streams. If you come down, you can see this stream status on. That's what we did, and we are going to trigger it Okay, whenever a new record comes, this gets triggered. What? This function. That is the Lambda function email service. That's how we created this trigger, this event trigger. So we completed this entire microservice thing, but now the only leftover part is the front end deployment. Okay, so most of the people don't know how to deploy a front end, right? So I'll just show you how we can do. Uh, so in front end, okay, the front end has to connect to backend, right? So the backend, which service we're going to connect to this API gateway to be specific. Okay, only this API gateway. So for this API gateway, we'll get an API this route ID, post request ID. Okay, I'm just printing it. Okay, in the outputs, but you can copy here, or else you can go to cloud formation, click on users, click on outputs. You can clearly see there is an endpoint URL here. Okay, anything is fine, both are good. You can copy it. Okay, why we are copying? Because the front end has to send a request to that API gateway. So that way, that's the reason you normally share to the front end people. Okay, this will be normally happen only once. Okay, they will be keeping this API URL here and save it, and this domain will not change. Each company has registered domain, so this API URL will be constant every time in the front end. Okay, they'll be changing it at once. That's it. So if you go to the front end, right? Okay, there is a index.html. There is like a form, a name and email. Okay, I said right. Once you just click on submit, it goes to this app.js script. It has a form add event listener on what when you submit a event, just will create clear all the unwanted default values, and just you'll read the date form entries, and this API URL, that is API gateway URL. You hit to it with a post method, and you'll give the headers like content type like application.json. So you can just ignore it this one, but you'll just create a request, and you'll get the text and just print it on the front end. Just to know like the email has sent, something like that will be printing out over here. That's it. In the output here. So you can see out. So this out is something like this one. Get alert. So yeah, so there is it's as simple as it. This is also serverless. So what we'll do is like we'll take this site folder. Okay, you can go to serverless file. You can come down. You can check here. This plugin to just sync it. You can just ignore it. But the main thing is like I said, I'll be showing Node also, right? Node language. So here you can see that the provider is AWS. The runtime is Node. Okay, this folder, this site, right? This will be running in Node runtime, and this is the region, and the stage is dev, and the custom. This is like to get the bucket name. We are going to create a S3 bucket, and we are going to deploy this front end to that bucket. And this S3 bucket has a good feature like I'll show you. I think I didn't deleted the S3 bucket. Yeah, so if you click on here, you can go to properties, come down, and you can see this static website hosting, right? Once you can edit and enable it, they'll say like give me the file name, just give index.html. Well, that's the file we added. Just save changes. That's it. So they just give the URL. You can just check it. They hosted this in a static way. Once you click it, you'll just see the file. So once you have the permission, you'll be able to see. If you don't have permission, you can always go back to the permission tab. You can add the proper policy resources and what action to be done. Okay, so that's I just want to show it, but let me just delete this project for now. Okay, let me just empty it so that it doesn't get confused for you. I just want to show how the static website hosting is given by S3 bucket. So I just delete this bucket. Okay, so if you see here, uh, so we are going to get create with the name like the stage name, the service name. That is the service name is this one, UI website, dev, and the bucket. So UI service hyphen dev hyphen bucket name is the bucket name for this S3 bucket. We're just syncing it. What we're syncing, this entire site folder is there, right? We are syncing into this bucket. That means we are going to copy paste it. That's it. That's the reason we added this plugin called Serverless S3 Sync. These plugins are given from serverless framework. Okay, you can always go refer it, but there is always documentation to refer it. Okay, and what resources we are going to create is the same thing. This bucket, right? This bucket we are going to give this bucket name. This one here, the properties, website configuration. We're going to give index document. Just now I showed you, right? Index.html I typed. That's the same thing they're adding from this script or this code, and public access configuration, right? So this thing, okay. Just now I showed you the public access. I enabled it, but here I'm disabling it. Okay, because no one has to have access other than the script. Okay, so public policy false, ignore public ACLs false, restrict public buckets false. If you can ignore these things, you can think like I'm just blocking the public access. Okay, and delete policy, I kept like delete. Why? This is like when I do SLS remove, right? It will delete the bucket. If you keep retain, it keeps it. There is like many scenarios. There is like bucket versioning. We keep the older version of UI so that they can go and revert back to the previous version. So they keep like retain, something like a keyword called retain, something like this. Okay, but I'm just deleting it for now to show you a nice practical and removing entire resources on a single click. Okay, and I'm adding a bucket policy here. Okay, who can access? They can only do get object. Here I added like action like uh, all actions on this S3, but I'm just giving get object only. Okay, it cannot do any port or any other thing because we don't need it on the S3 bucket. Okay, we are sending the data to this other serverless. Here we're posting, but for this application, we don't have to require anything other than get object because we're going to get the index.html page. That's it. And what resources? Entire thing on the S3. But we can always specify which files to be accessed. Okay, and that's it. We added this policy and outputs. I'm just giving the website URL, right? Whatever the website is getting created, we are going to get the URL. Okay, and yep, that's it. We can now deploy this file. Okay, and let me show you how to deploy it. Okay, this is as easy it is. Just you can do like SLS deploy similarly because we are doing with serverless framework. Once you deploy it, you'll get a URL. Okay, here or in the outputs folder because we added in the outputs. Let me show you once it gets deployed. The only thing in the front end to be changed is this URL because we don't have a domain name. That's the reason we are going to get a unique API gateway URL once you redeploy the this Lambda, this one. So yeah, it's building. You can just go to the dashboard, CloudFormation dashboard. You can do a refresh. You can see it. You can come here, check the resources, what it's creating, create in progress with the policy name, policy, and it will attach the policy to this bucket. So it has attached, it got completed. You can see, I think I didn't print it out here, but you can just go to the outputs. You'll get the URL. Just you can click. You can do like open as link or copy the link address. You can open it in the new URL link. You can see here. Okay, you can always go to inspect tab, click on network, and just refresh it. You'll just say like this page is loaded. Excuse. So you just give some data. Okay, I'm just giving this mail ID to send it. Okay, it's registered with my uh, SES. So I'm just giving the same email ID. Once you just submit, just see what happens. So you can clearly see there is a post request and the optional request. I said it's a pre-flight request. It will check if there are any chorus errors or not. In the register, you can see there is a post went to this API gateway. That is this API gateway, and that API gateway redirects the request to this store user, and the store user stores the data in the DynamoDB table. You can come here, explore table items, run it. You should see it. Why we are not seeing it? Because once you add it, okay, the data will be sent to this Lambda, that is send email. Okay, this send email, what it does, it sends the data to the email. So once you just refresh it, you should definitely see a new email here. So this is the name I gave, so that's why it sent a email to me. And once the email is sent, what this email Lambda service do, goes to this table, deletes the data within this table. So you should be very quick to see this action. Okay, so this is a good example. This is complete end-to-end project. Okay, and we learned about a lot of things today: microservices, chorus, and complete project, and how to deploy the front-end application in S3. Okay, we normally do this front-end and deploy it. And the good part in the serverless is just do like SLS remove. That's it. Just a single button for all the repos for backend and this thing. We can even automate this, right? Just to run this SLS remove for all the microservice, and just it just removes and destroy entire service. So yeah, that's it from my end from this project, complete project. So we started from basic basic things of AWS. What is a cloud provider and why we need it? What are the challenges we faced, and even why we are moving to AWS and the advantages of AWS. And we learned a lot of services of serverless, and we learned serverless framework as such, and we automated all the services, and we built a complete like we built smaller projects first, single projects, and now we built a complete microservice based project. So this is a lot of things we learned in this small crash course, but in future I'm going to launch a big project, or we are going to like start a new course for learning each and every service of AWS. more than 15 to 20 microservices or services we're going to serve, like learn. So just comment down below if you are interested in learning and learn like deeper concepts of how these services are created internally by AWS team. Okay, we're going to do a lot of research and do a lot of like analysis and learn a lot of internals of each service, how they created, and it will be a big achievement if you learn entire cloud architecture, how they build, and how they are handling all the data centers and regions and everything, how they're optimizing in the backend, right, and maintaining the high availability and durability, and a lot of concepts are there in the cloud world. So in future we can have this course. Just comment down below, and based on the request I'll create a nice project for you all guys. So yeah, that's it from my end. So have a good day. Bye.